Hello everyone, I'm Aaron and I'm going to say a little bit about my PhD research on seafloor ecosystems. The research is part of a larger blue economy project aimed at understanding depositional footprints associated with offshore aquaculture, which sits within the Environment and Ecosystems Research Program. Largely what we're interested in is how the seafloor and sediments will respond to increases in organic load. The challenge here is it's complicated. We have bacterial and faunal populations, as shown in the illustration, which develop in relation to their surrounding environment and depend on things like the supply of natural organic matter, sediment characteristics, and bottom water conditions. And what this dependence on a variety of factors means is it's not straightforward to predict the response. And this is in part what motivates us to seek models which can describe underlying processes. These models become particularly useful when we move into offshore regions where empirical data is lacking and environmental conditions are in contrast to traditional inshore farming locations, where models provide a way to try to account for this. As a part of the larger Blue Economy project, the team in New Zealand have been doing some great work out in the field and back in the lab trying to understand these benthic responses experimentally and how we can measure them. They've generated a bunch of data that can also be used to test our models. When we put together a model, we take our imperfect understanding of the underlying processes and encode it in a model. And so what we want to do is compare model outputs against observations to be confident that we have accurately captured the most important underlying processes. And so what type of contributions can the work make to the blue economy? To measure depositional footprints, equipment like this benthic chamber lander is sent down to the seabed to measure things like sediment oxygen consumption and the return of nutrients. Models can provide another layer of interpretation for the data and inform us on what spatial scales and how often we should sample to strike a balance between the detail of our understanding and the monitoring effort. On the planning side, we can create maps similar to the illustration on the right that account for a combination of environmental characteristics and highlight benthic regions that might be more sensitive than others to increased organic load, which may be considered in planning activities. Perhaps the most useful aspect is these tailored benthic models' inclusion in larger models to evaluate scenarios. Environmental impacts may be predicted for specific farm locations, sizes, and operating conditions, providing great insight into environment and ecosystem outcomes for competing space allocations. And that rounds out my presentation. I hope you enjoyed it. These are the references for the illustrations. Have a good day.